Okay, good morning, all of you. So just wait, I am starting. Okay, good morning, all of you. Am I audible? Please confirm me, anyone. Am I audible or not? Good morning, everyone. Am I audible?
Yes, sir.
Okay. Okay, so let's start. So we have discussed in our last module. So that is, we have to cover different types of, that is block diagram reduction techniques. Then we have to cover the signal flow graph methods. Okay. So now we have start, that is module 2. So in your module 2, okay, I think all of you see the syllabus. That is module 2. We have to solve, that is time response. Okay, time domain analysis or time response analysis of control system, and as well as also frequency domain analysis. So in this module 2, we have to cover time response analysis of the control system and also frequency response analysis. Okay, so first of all, what is time response analysis? Okay, so in this chapter, we have to cover this time response analysis. It is basically one feedback control systems. Okay, so this state signal, it is specified into the different types of functions, that is unit step functions, unit ramp functions, unit parabolic functions, and unit impulse functions. Okay, so first of all, we have to tell this times response analysis or time domain analysis of a control system. It means as how a system, okay, how a system it behaves according to the timing, okay, with respect to the timing when a specified input signal we have to apply. So first we have to know the definition of the time response analysis any control system. So it means as to how a system behaves. My slide is visible, all of you?
Yes, sir.
Okay. In accordance with time, this is very important, with time, when a specified input, when a specifically input test signal is applied. Okay, so this is the basically definition what is time response analysis any control systems. So this time response analysis of control systems, it means as how a system behaves in accordance with respect to also timing when you have to apply, that is user it is applied specified input signal, specified input test signal is applied. Okay, so this is called the time response analysis. Okay, so this time response analysis we have to know in this chapter, it is basically two parts. Okay, this time response is divided into two parts, two parts. One is transient and another one is the steady state. Okay, so please remember these things. This time response analysis we have to classify into first category into two categories. First one, that is a transient response, another one is the steady state response. So in this transient response we have to cover, that is first order system and as well as also second order control systems. Okay, so this transient response we have to cover first order system and as well as also second order control system, and it can be uses in the under damped and critically damped and over damped of the different types of value of the damping ratios also. Okay, later part we have to discover, we have to discuss in details in transient response, and another one is the steady state response analysis. Okay, up to this part it is clear all of you. So this time response analysis, first we have to start it in any control system. This transient it is appear, and during this post transient past it is a steady state error. So first we have to start, that is a transient control systems, a transient analysis. During the post transient part it is also steady state part also. So this steady state means it is a state, it is a state of the output of the control system with respect to the time. Okay, so this is very important terms. So first we have to discover, that is the two parts, transient response analysis and steady state analysis. So just you can see one examples, this is very clear for you. With respect to time, this is input response, and we know that in our transfer functions we represent, that is rt, it is a input function, this is a one, means that is a unit response, and when it is input test signal, this is input test signal, this is the input of the first step. Okay, when this is rt that is equal to 1, that is my unit step input, so this is the input test signal. When you have to discover the output response, so output is also changes after the different, that is a transient response and later part of the steady state response also. So graphically structure is coming just so that something like that. Okay, so this is basically okay. So in this part where is located, this is basically two parts. This is, sorry, this is output, and with respect to the timing also, and we represent the output signal into our transfer function, that is CT, all of you known. Okay, so these are the basically two divisions we have to follow in the output equation. First one, this part, that is a zero, that is the starting point, that is a zero. So this part to this part, this is called the transient response. Okay, this is transient part, and after this point, this is called the steady state. This is called steady state. Up to the steady state, wherever, not stop, that is the output. Okay, and in this point we have to call, that is steady state error. This is steady state error. This point we have to tell, that is the steady state error. Okay, so this part it is clear. So in this time response of analysis in any control system, it means how a system behaves according with respect to the timing. This is timing. When you have to apply any specified input signals to apply it into the systems. So this time response analysis classified into two categories. First one, that is a transient response, another one is the steady state response. So we have to examine, that is a typically one examples we have to given, one input signals we have to test it from here. This is input signals when RT that is equal to 1 means that is unit step functions in our input test signals. And when you have to follow this output signal, it is two parts. One is the transient parts, another one is the steady state response analysis. So this 0 to this step, this changes, this is big changes. Here you can see this is gradually increases, then you have to first peak value, then slowly decrease, then increase. So these are the basically basic pattern. This part we have to call, that is transient response in our time response analysis. And after this point, this result, it is steady state, that is stable, near to stable. So this point it is called the steady state regions also. Okay, it is clear all of you? Please respond me, it is clear or not? Okay, okay. So this transient part of the time response analysis, it reveals the nature of the response in the oscillatory or any overdamped systems. Okay, that means oscillatory, that means we have to use this that is CRO, cathode ray oscilloscope. So in this oscillatory device we have to response, we have to capture in this transient response, and it also gives a indication about the system speeds. Okay, so this transient response analysis, we have to ideal characteristics for the indication about the system speeds, that is how many speeds are this motor is rotating, something like that. Okay, and this steady state part, it is a time response reveals the accuracy of the control systems. Okay, so just remember these two things. With respect to the transient time response, we have to measure, or we have to indicate the speed of the system, and steady state response, we have to measure the accuracy of the control systems. So these are the basically time response analysis. Okay, it is clear all of you? Anyone any doubts? So please ask me. Next part, we have to discover the different input signals, okay, in our time response analysis. Input test signal. So in this specified input test signal, it is applied for the time response analysis of a control system in different format. First, step functions. Step functions. Number two, this is ramp functions. Number three, parabolic functions. Number four, impulse functions. So these four type test signal we have to use in our time response analysis of a control system. Number one, step functions. Number two, a ramp function. Number three, parabolic functions. And number four, impulse functions. Okay. So first we have to start the step functions. Okay. So this test function, it is basically describe the certain application of input signal. Okay. So when you have to apply the any input signals, that means the graphically we have to represent it here. This is input signal. We know that we represent that is RT. Okay. With respect to the timing also, it is very important because we with respect to time we have to observe the time response analysis, and these are the basically value of the R, that means input value. Okay. So this is the starting point when you have to apply these input state signals in either it is also unity feedback system or any zero control, that is zero systems also, that is zero order system, first order system, second order system. There are different order systems functions we have to apply here. So in the step functions it is described certain application of input signals when it is also applied. This is RT, it is equal to R when that is T is greater than equal to 0, and when RT that is equal to 0 when T is less than 0. So remember these two conditions. When this input response, that is RT, that is equals to R, this value it is same to same. When this timing T, it is greater than, either greater or equals to 0, and when RT is 0, that is T is always less than 0. Okay, so these are the basically step functions, replacement functions also. This is step functions representations. So in the step functions, when this is R is, that is the 1, we know that when R is 1, that means it is called the unit step functions. All of you known. When feedback it is 1, it is, we have to call that is unit feedback system, or that is this is a unit step functions. Okay, so this unit step functions, it is corresponding, we have to take the Laplace transforms. So when we have to apply the Laplace transform, that is R equals to, that is 1, that is Laplace of 1, that is value is 1 by S. So please remember these things, because these are the basically step functions of the time response analysis. So these step functions, sometimes it is also called displacement functions. Okay, so these step functions is also called displacement functions. Okay. So this is the step functions, the equation that is when r is 1, that is a unit step functions. Okay, this unit step function, that is the Laplace of unit, that is the r, Laplace of r, that means value is 1. This value is in our Laplace formula, that is 1 by s. So this 1 by s, this is for the step functions, and this step function, it is also called the displacement functions. Okay, it is clear, all of you?
Yes, sir.
Yes, sir.
Okay, so we can go next. Next, number 2, that is ramp functions. This is ramp functions. So this ramp function, it is basically describe, we have to gradual applications of the input signal. That means example is gradually increased. So it is also a straight line, something like that. This is RT, input functions, with respect to always the timing. And this slope, this is basically called the R. Okay, so and also this is starting point 0. The time is increases. This slope, it is also gradually increases value. So the condition here, when RT that is equal to R into T, that means the step input with respect to also timing, for also always when T greater than equals to 0, and when RT equals to 0, that means for when T is less than 1. So these two conditions, please remember always. So when ramp functions, we have to describe this. It is gradually application of the input signals. Okay. So when this RT that is equal to R into T, when the time T is greater than, either greater than or equals to 0, and when RT, that is the input, is 0, that means T is less than always 0. So in this condition, we have to apply, that is R equals to 1. We know that, that is when R is 1, that is the unit step functions. And that is equals to 1, because when R is 1, the function is coming RT, that is equals to T. So this is basically called the ramp functions. This is basically called ramp functions of these equations. So we take the Laplace transforms, that is T, because T is the basically when R is equals to 1, the function is also T. So that T is the value, the formula is 1 by a square. So please remember these things. When ramp input, we have to calculate it in our time response analysis in control system. The function is coming 1 by a square. And this ramp functions, it is also called velocity functions. Okay, this is also called velocity function. So please remember these things also. First step function, we have to call also displacement functions, and the function is, that is 1 by s. In the ramp functions, it is also called the velocity functions, and the function is 1 by a square. Okay, it is clear, all of you? Next part, number 3, that is parabolic functions. Parabolic functions. So this parabolic function, we have to describe these more gradual applications in any input comparison with the ramp functions also. So ramp, when we have to consider the ramp functions, it is gradually increase in straight line, but when you have to parabolic, the structure that is the this type of curve it is present. Okay, so this is called the parabolic functions. This is also input function, that is rt, with respect to the timing starting point, that is 0. That means when parabolic functions we have to describe in our time response analysis and control system, it is more gradually applications of the input of the comparison of the ramp functions also. Okay, so this is basically slope rt. Okay, so that means the function is coming when rt that is equals to rt square by 2, when t is always greater than or equal to 0, and when this is 0, that is rt is 0, always t is also less than 0. Okay, so this is the basically functions of the parabolic function, that is rt equals to rt square by 2. So now we have to apply, if r equals to 1, the function is coming, that is rt equals to t square by 2. Okay, so this is basically rt equals to t square by 2 in the unit step functions. So this is called the parabolic functions. Parabolic functions. Now we have to apply the Laplace transforms in these functions. So we have to easily written that is Laplace of t square by 2. So it is formulated, that is 1 by s cube. So please remember these things. So all of you seen the Laplace transformations in your mathematics. So please go through the Laplace analysis of the mathematical expression. Here are lots of rules, that is formula is given. So you have to see this first Laplace of, that is s, that is the Laplace of t, that is equals to formula 1 by s. And when you have to go the Laplace of transformation of any t, that is a ramp function, that is 1 by s square also. When you have to parabolic function, that is Laplace of t square by 2, that is 1 by s cube, and so on. So here are lots of functions are available in our Laplace transform. So these parabolic functions, it is also called the accelerations functions. Okay. This parabolic function is also called accelerations. Functions also. Okay, this is clear all of you. So this parabolic functions, this is 1 by s cube. It is clear all of you. No one is
Yes, sir.
okay. So everyone write your own name and roll number in the chat box also, and please take a screenshot. Okay, Gautam is present. Gautam, you take a screenshot, okay? In one page.
Yes, sir.
Okay. So now we can go the next one, that is a parabolic, that is a impulse functions. Number 4, impulse functions. So these impulse functions we have to apply in our time domain analysis. This input is suddenly applied as a very short durations of the time. So when you have to apply the impulse functions in our time domain analysis or time response analysis in any control systems, we have to apply very short duration of time. Okay, when you have to apply this any control system, any time response, it is usually very short duration of time. So please remember these terms also. So you have to graphically show that. So this is input functions, that is RT, with respect to the timing also. So first of all, when it is starting, the first little bit timing it is present. This is also R, the value of slope in the impulse functions. Okay, this is starting point, that is 0, and this distance, these two distance, it is represent, that is the delta t, and these are the basically short distance of the timing. Okay, so when any systems we have to apply in any short duration, very short durations, so this function we have to apply, that is called impulse functions. Okay, and this here delta t we have to naming in that point, that is 0 to certain limitation of time, very short duration time, we have to represent delta t. So this basically, this impulse functions, it is related in our unit step functions. So we rewrite these equations, that is unit impulse functions, that is equals to ddt of, so we know that ddt, that means that with respect to change of timing in any very short duration, so with respect to the timing of the unit step functions. Okay, so now we take the Laplace transform in both sides, so that means the Laplace of, that is the unit impulse functions, obviously that is Laplace of ddt of unit step functions. Okay, so we know that when this system we have to apply the Laplace transform here, so the function is coming also, that is Laplace of unit impulse functions. This is S for step functions, we have to use S, ddt of, that is functions of ddt of, that is S, Laplace of unit step functions. So now we have to write Laplace of unit impulse function, that is equals to S dot, we have to calculate it, this Laplace of unit step function in our number 1, the value is 1 by S. Please go through the first step functions we have to discuss in earlier slide also. So value of Laplace of unit step function is coming 1 by S. So that means S and S, this S and this S, the value is also 1. So the function is unit impulse functions, that is also 1. Okay, so please remember these things when you have to apply the any impulse functions in our time domain analysis. It is basically uses in very short durations of the timing. Okay, so that means we have to apply here starting point to the very short distance we have to apply, these are the delta t. Okay, so this unit step function, it is represent ddt, that is with respect to the timing changes, unit step function, we take the Laplace in the both sides, the function is coming, that is the Laplace of unit impulse functions, that is equals to 1. So these are the basically 4 test signal. Okay, so first we have to cover that is step functions. Okay, the function is coming, that is 1 by s, then ramp functions, that is 1 by a square. Then we have to discover that is the parabolic functions, that is 1 by s cube, and last impulse functions, the function is coming, that is 1. Okay, so these are the basically input test signal we have to apply it in our time response analysis. It is clear, all of you? Please respond me, it is clear or not? Am I audible?
Yes, sir.
Okay. Okay, so anyone any doubt or any question, so please ask me. And everyone, please write your own name and roll number in the chat box, because right now 28 responses are received. 10 students are not written right now. So please everyone write your own name. Next part, that is a time response in a first order control systems. Time response of a first order control system. Okay, so this first order control system, it is basically one highest power in of the S. Okay, this S is denominator of the transfer functions, that is equals to 1. So just wait, I am drawing you one first order control systems. All of you known, because we have to cover in our first module. Lots of diagram we have to learn in block diagram techniques and signal flow graph techniques also. Okay, so these are basically a diagram of the first order control systems, all of you know. This is summing point. So first we have to apply that is input, with that is RS. This is a basically process or plan, that means controller part, and this is the output part we have to know, that is CS, and this is the summing point, and after summing point we have to calculate that is any types of error. This is positive and this is negative, and these are the basically feedback loops. Okay, that means this is a basically a closed loop control systems. This is block diagram of a first order control systems. Okay, so in this first order control system, where we have to use the highest power of the S, that means when first order system, that is S value, that is a 1. So we have to written this equation, that is output by input. We have to know this is equals to transfer function, that is TF, transfer function, that is equals to output by input. So we have to written CS by RS, that is equals to 1 by S into T plus 1. So please remember these things also. Okay, so this is the time response analysis of the first order control system. So again, these equations. Okay, so it will continue in next classes. Okay, so thanks everyone. Anyone any doubts, so please ask me.
I'm getting